Good morning, sir.
Good morning. So, Baljinder, what do you want? You want Snap for
Yes, sir.
thermodynamics? So, what are you prepared for today? Uh, like this particular Snap? Entire thermodynamics?
Yes, sir. Actually, the previous one was pretty bad for
Mhm.
me as it, so I decided to move it another shot.
Okay, let's start your mock, Baljinder. Baljinder, what
Yes.
do you mean by ideal gas?
Sir, ideal gas is the one which follows the equation PV equals MIT, that is ideal gas equation, and we consider that ideal gas there is no particular volume of a single particle that is they are point particles, and there is no interaction between them. I mean, though no force of attraction between any two particles.
I think you heard about van der Waals equation.
Yes, sir.
तो आइडियल गैस इक्वेशन तो आपने बताया कि आइडियल गैस follows आइडियल गैस इक्वेशन. What is that van der Waals equation?
Sir, in actual real gases only follows the behavior of ideal gas at very low pressure and very high temperature. But in all other cases, they don't follows the equation PV equals MRT. So we have to give an equation for real gases, that is van der Waals equation. One of the equation is van der Waals equation, which is P plus A by V square into V minus NV equals MRT.
Mm-hmm. Okay. Okay, suppose Baljinder, if you will give you some piston cylinder arrangement, okay,
Yes.
and suppose there is some ideal gas inside that
Yes.
piston cylinder arrangement,
Yes, sir.
you are supplying some heat into
Yes,
this
sir.
chamber, piston
Yes,
cylinder
sir.
arrangement, by attaching some kind of heating coil in this. There is some
Yes,
heating
sir.
coil through which you are supplying energy.
Okay, sir.
Okay.
Yeah, okay, sir.
So Baljinder, if there is some expansion is taking place.
Yes, sir.
So first, just write the first law of thermodynamics for this.
Okay, sir. So for the coil will supply some electrical energy that is in
Mhm.
form of that can say work. So we'll supply some del W work into the system. So work will be negative, and uh, that will convert into heat. So we can, if according to first law of thermodynamics, del Q equals du plus del W, and we assume that all the heat is converted into internal energy. Then, oh, so del Q equals, if I assume that temperature is remaining constant because of constant pressure process, that is, if we supply heat and the piston is going to expand, then del Q will be equal to the PdV work that will give the piston by expanding upwards.
How is that it is a constant pressure process?
Oh, sir, I assume that it is a constant pressure process.
You assumed it is a constant pressure.
Yes, sir.
So okay. So again, just show me the equation. What will be the equation for first law of thermodynamics for this process?
Sir, if
Expansion
I
process.
write del
Mhm.
Q equals du plus PdV, then du will be 0, and all the heat added will be equal to the PdV work.
Why du is
Uh,
zero?
Sir, because I'm assuming if all the heat,
Isothermal. You're assuming it
uh,
isothermal.
no, sir, actually, I'm assuming that all the heat that will adding is just expanding the gas. So all the, oh, according to first law, all the heat is giving work. According to second law, that is not possible. That some of will convert into internal energy.
Obviously.
So obviously, yeah. So uh, that del Q, sir, I don't think we can. That isn't a boundary.
Mhm.
So del Q can be assumed 0 du plus PdV. Uh, so that del Q isn't that heat that we are adding isn't crossing the boundary. It is generating within because we have uh, installed a coil. So the del Q are we supplying, and sorry, del W that we are supplying equals will increase. Uh, just a second, sir.
Mhm.
Uh,
I just suppose for simplification purpose, if you will assume this piston cylinder arrangement as an adiabatic,
yes, sir.
okay,
Then all the given to the coil is going to convert uh, into internal energy, I guess, and some will be used to also expand the piston.
yes. If you will assume adiabatic, then yes, then there will be some change in the internal energy also and work output also.
Yes, sir.
But if you will not consider it adiabatic, then heat loss will also be there. That heat transfer can
Yeah,
also be there,
heat transfer will be
and
all out of boundary.
internal energy, change in internal energy, and the work
Work
will also
PDB
be there.
work.
Expansion
PDB
work,
work.
PDV work.
Yes, yes.
Fine. So for this gas, the gas inside this, suppose you want to calculate the entropy change. How you will calculate the entropy change?
Sir, all the gas is getting heat which is equal to the heat that the coil is generating. So its temperature, if I assume is gonna increase, then delta S will be equals to uh, M. If I it's sir, it's going to expand, right? Can I
Yes,
assume
yes.
it's constant pressure or any constant pressure process? Can I assume?
Okay, fine. Go ahead. Go ahead. Assume.
Okay, sir. So change in entropy is going to be mCp log T2 by T1 minus mass into R log uh, P2 by P1. So log P2 by P1 is going to be equal to 0 because of constant pressure process, and its delta S will be equals to mCp into log final temperature. That is change in entropy.
Achha, when you are assuming this piston cylinder arrangement as an adiabatic system,
Yes, sir.
what will be the entropy change of the surrounding?
0.
Why?
Sir, because no heat is going to release from the system to surrounding. There is no.
But work is
So,
entering. Work is entering like
sir,
in heating coil.
sir, but work is a like is not a random energy. It is an organized energy. So there isn't any entropy associated with work.
Hmm. Baljinder, what is CP and CV?
Sir,
What they
CP
are
and C.
representing?
Sir, these are the specific heats for gas. CP represent what amount of energy heat that we give to a gas at of 1 unit mass to raise its temperature by 1 degree Celsius at constant pressure process. And CV is the same, but we do the temperature raise by constant volume process by one
So
degree.
which one is more and why?
Sir, CP is more because if we use the constant pressure process, then as we heat the gas, there is going to be some expansion, and that will be some of heat will be converted into PDV work. So we have to give more heat, so CP will be more compared to CV.
Hmm. Fine. So Baljinder, can you tell me something about second law of thermodynamics?
Sir, second law is the law that tells us about the quality and quality or direction of any process. It has two statements. First one is the Kelvin-Planck statement, which states that it is impossible to construct a device which will which will give us net work by just interacting with single reservoir. And second statement is Calvin Planck, Clausius statement, which tells us that it is impossible to construct a device which will transfer heat from high temperature to lower temperature without any external energy interaction.
What's the difference between heat pump and refrigerator, Baljinder?
Sir, heat pump is we use to uh, give heat from higher lower temperature to higher temperature. That is also that uh, that is also the process that refrigerator do. But in heat pump, our uh, uh, desired process, a desired heat is at higher temperature reservoir or higher temperature like side. But in refrigerator, our desired consideration is at lower temperatures.
Baljinder, if you will compare heat pump with a heater,
Yes, sir.
which will be more efficient?
Sir, heat pump will be more efficient.
Why?
Sir, because if we use a heater, that will just convert the work that we're giving it convert into heat. COP will be 1, we can say. And for heat pump, it will also take some heat from surrounding and add work in it, so it will give more heat to the space that in which we want our heat to come. So for the same work input, our heat pump will be more efficient.
Heat pump will be more efficient. Yes, sir.
Yes, sir.
Okay. Okay, suppose you attached some heat pump. आपने कोई room ले, like suppose if we consider some room,
Okay, sir.
you attach some heat pump in that room.
Okay, sir.
Okay. To maintain
Okay.
some high temperature inside the room as compared to the atmospheric temperature,
Okay.
you attach some heat pump. Like suppose
Okay.
now if you will consider the steady state conditions,
Hmm.
steady state conditions inside this room,
Okay, sir.
how you will calculate the entropy generation for this?
Entropy generation, sir. What heat pump will do, it will uh, get the heat from the surrounding, suppose that Q1 heat, and will give some work input W to heat pump, and it will supply W plus Q1 heat to the room. So, and if room is having a temperature, suppose T2, and surrounding is having temperature T1, then the entropy for the surrounding that is decreasing, that we can write delta S surrounding equals Q1 by T, because Q1 is heat extracted for surrounding and its temperature is at steady state T1. And for entropy is increasing by W plus Q1 divided by T2. So, and net entropy generation will be entropy of the room minus the entropy of the surrounding.
So entropy generation, what is that entropy generation, Baljinder, and what information we are getting from entropy generation?
Sir, entropy generation, we are getting that the amount, the work that we have, call it, I mean, directional energy is converted into heat. So its quality is degrading and it will produce, and there was some work that we cannot uh, cannot get that we earlier can get if we converted that work into in another mechanical energy like something kinetic energy or anything else. So entropy generation is basically telling us that there are irreversibilities in the process, and there is increase in unavailable energy, and our available energy is getting low.
What will be entropy generation in case of a reversible process?
Zero, sir.
Zero. From where
Yes.
actually we are getting this information?
Yes, sir.
There is some Clausius theorem. You heard about this Clausius theorem?
Yes, sir. It's Clausius theorem says that del Q by T for a cyclic process will be always less than equal to zero.
Mhm. So from where actually we are getting this equation?
Del Q by T
Yes, yes.
less than equal to zero. So basically, sir, this we're getting from entropy itself, that it represents del Q by T is represents a property that we
So
named as
that is a kind of Clausius inequality you defined. That's fine.
yes,
But
sir.
what is that Clausius theorem? Clausius inequality is different thing. Clausius theorem is different thing. I'm asking you Clausius theorem, not
Theorem.
Clausius inequality. Yes, yes.
So Clausius theorem, that I can't recall, sir. Clausius theorem.
Something about like any path, any reversible path, we can represent with the help of the two uh, isentropic processes and one isothermal processes.
Clausius theorem, that it states that the if uh, two adiabatic processes, they will never intersect
Mm-hmm.
on any indicated diagram,
Mm-hmm.
because if they will intersect and we draw an isothermal process,
So what is that
so
theorem? What is that theorem?
uh, sir, uh, I can't remember exactly. I'm just telling you, but I can recall that you
Okay.
told me.
Okay, Baljinder, my last question is to you. What do you mean by reversible process? What is a reversible process?
Sir, a reversible process is a process in which every state of system is at equilibrium, and at every moment of the process we can reverse our process at initial stage without leaving any trace on the surrounding.
Hmm. Fine. Baljinder, let me give you the feedback.
Okay, sir.
So, Baljinder, I asked you just a second. Let me pick the page. Just a second. Okay, so I asked you some questions initially from ideal gas. What is the ideal gas?
Okay.
You mentioned ideal gas follows the ideal gas equation. But
Yes,
उससे
sir.
अलग you know to define the ideal gas also. There is ideal gas equation, fine. Ideal gas follows ideal gas equation. But ideal gas का मतलब क्या होता है? Gas are in which there is the intermolecular force of attraction is negligible between the gas
Yes,
molecule,
yes,
and those molecules are only colliding with each other. So there is only interaction is there between the molecule. There is molecular collision. There is no intermolecular force of attraction. So that's why the energy of the ideal gas is only the energy due to its kinetic energy of the molecule.
mm,
So pointed mass मानते हैं हम. The gas particles are pointed mass. They are not having any volume. But for real gases, the gas particles,
have
they will
a
have some volume. So
considerable.
that's why if you will consider that, and if you will consider the molecular interaction also, other than the molecular collision, that pressure will also change. So that's why the van der Waals equation that will take into consideration of the molecular interaction also. That's why we will have term P plus A. That term is
I
there.
B V square.
Yes.
Yes, sir.
Similarly, we are having term
V
in
minus
the
B. V
yes.
minus B.
So why? Because we are considering the volume of the
Volume of
gas
the
molecule. That
particles.
is. So you mentioned about that, but ये चीजें आप उसमें और add कर सकते हो.
Okay.
After that, I asked you about the case, some piston cylinder arrangement. There is some gas inside that.
Sir, actually, I got confused in that case. Can you
Mm-hmm.
tell me about, मतलब अच्छे से थोड़ा?
Mm-hmm. DQ, like this is a piston cylinder arrangement, and you are attaching some kind of heating coil in that. And with that
Yes,
heating
sir.
coil, what you are doing? You are supplying some work.
Yes, sir.
So if you write first law of thermodynamics, so first law of thermodynamics will be dq equal to du plus dw.
Yes, sir.
So dq you cannot say, like, unless otherwise it is not mentioned, you cannot say it will be there. This will be there. dq will be there. Heat transfer.
Sir, but dq is not any crossing any boundary.
Yes,
Okay, sir. It
like
isn't an adiabatic.
piston is not insulated, na.
Yes, sir. It is
If
an
you will assume,
adiabatic.
if you will assume it
Adiabatic.
is insulated, then you can assume, because there will be no
Okay.
heat interaction. Like outside से कोई heat नहीं आ रहा है, but अंदर का heat बाहर ना जाए. For that, the piston cylinder is required to be insulated.
Yes.
If you will assume, sir, it is insulated, then you can go ahead with that assumption. dq will be 0.
Yes.
Otherwise, du will be the change in internal energy, and you cannot say du will be 0. Du will be 0 if the process is isothermal, because ideal gas is there. And if you are saying ki du is 0, then the process, that temperature will be same. Are you
Okay.
getting? So when you are
So
considering it constant pressure, so du will be there. What will be du? It will be CVDT,
yes.
because change in internal energy of an ideal gas is CVDT. Now the next thing comes to work. There are two type of work interaction. One is the expansion work, and another is the work done on the system.
Yes.
Work done on the system is the electrical work, that is negative work.
Yes.
What voltage, what current you are supplying, V into I.
Yes.
What is the work you are getting? That's the expansion work. That will be integration VDP, PDV. Integration PDV closed system है, reversible. You can go ahead with that. Reversible तो मान ही सकते हो, closed system.
Yes, sir.
And now if you will consider it as a constant pressure and that adiabatic system, insulated अगर आप मान ले, then dq will be 0. So m mass specific term में लिख रहा हूँ because closed system है, तो mass में नहीं consider कर रहा. So m CVDT plus PDV, that is equal to the electrical work. The electrical work done on the gas, that will result into what? Raise in internal energy plus the expansion work.
Okay.
The work, the energy which you are supplying, electric energy V into I, that will be equal to raise in its internal energy plus expansion work, means CVDT plus PDV.
ADB. Yes.
ये कंक्लूजन आप एनर्जी बैलेंस यहाँ से आप निकाल सकते हो. ठीक है, समझे ना?
So basically, I have to first mention the assumptions that I'm making, that adiabatic or isothermal.
Yes. तो पहले जनरल केस लेके चलो ना. And even if you are not getting any conclusion, so you can ask the interviewer, so can I assume this? Then he can give you some hint. But अपनी तरफ से अगर आप assume कर रहे हो, you have to mention that.
Okay.
आप ये नहीं बोल सकते sir du will be 0. Why it will be 0? You have to give the reason ना.
Yes.
First give the reason, then you can highlight.
Okay.
अब एक ही चीज मानोगे ना, like you can assume sir isothermal मान लूं मैं. You can assume isothermal also. आइसोथर्मल मान ले तो क्या करते? देन du आप 0 मान लेते. आइसोथर्मल एक्सपेंशन भी तो हो सकता है ना. देन आपका वर्क जो होता है इंटीग्रेशन पीडीवी, दैट यू विल बी एबल टू राइट इन टर्म्स ऑफ P1 V1 ln of P2 by V1.
Yes.
P1 V1 ln of P2 by V1, that is isothermal work.
That I get.
तो इसमें सराउंडिंग का एंट्रोपी कैसे निकालोगे? दैट वो सराउंडिंग एंट्रोपी विल बी 0. ओके,
Zero.
विल बी 0. एंड system entropy you will be easily able to find out, because ideal gas is there, and if you know the initial pressure temperature volume or final pressure temperature volume, you will be able to
That.
yes. अगर कोई एक कैलकुलेट एक कोई कांस्टेंट है, then it is very easy to calculate.
Yes.
because second one से आप easily आप इसको कैलकुलेट कर सकते हो.
Yes.
second law you mentioned, but आप heat pump और refrigerator में confuse हो गए बलजीत सर. very simple thing.
Yes.
heat pump और refrigerator, तो थोड़ा देखना है इसको. Heat pump is a device, a cyclic device, which we use to extract heat from a low temperature body, supply it to high temperature body with some work input.
Right.
Heat refrigerator भी same है, but supply की जगह मैं क्या बोल दूंगा? reject बोल दूंगा.
Extract.
Heat refrigerator is a device which extracts heat continuously from a low temperature body, reject it to high temperature body with some work input. but दोनों में difference क्या है? Heat pump is used to maintain the high temperature.
System high
supplying
temperature.
supply heat करके हम high temperature maintain कर रहे हैं. And refrigerator is used to maintain the low temperature by extracting the heat. तो वो जो heat pump वाला क्वेश्चन मैंने आपको पूछा था, उसमें क्या हो जाएगा? स्टेडी स्टेट में है, रूम इज इन स्टेडी स्टेट, तो नेट आपका हीट ट्रांसफर क्या होगा? लाइक फ्रॉम द सराउंडिंग, व्हाट इज द हीट यू आर टेकिंग? यू आर टेकिंग सम हीट, यू आर रिजेक्टिंग इनटू द एटमॉस्फेयर. आप अपना रूम में आप रिजेक्ट कर रहे हो. रूम आपका स्टेडी स्टेट में है,
तो टेम्परेचर कांस्टेंट रहेगा विद रिस्पेक्ट टू टाइम.
आपका टेम्परेचर क्या हो जाएगा, कांस्टेंट हो जाएगा.
Constant. Yes.
बट एक्चुअली व्हाट इज हैपनिंग इनसाइड, यू आर टेकिंग सम हीट, बट व्हाट इज द हीट गोइंग अगेन इनटू द रूम, हीट जा भी तो रहा है रूम में. Because if the heat actually you are supplying in reversible case, the heat which you are supplying, the same heat is leaking also. The heat is leaking out also from the room. Because then only what we are saying steady state. Energy in equal to energy out. So energy in कौन सा हो रहा है?
Okay. Oh, so that I didn't assume that.
Steady state मानेंगे तो हम energy in energy out बोलेंगे, तो energy in कितना हो रहा है? That is what you can say, the heat supplied by the heat pump. Okay, that is energy in, and energy out भी तो होगा, that is the heat lost by the room, and both are same.
Okay, sir.
Okay, with that you will be able to calculate the entropy change.
Okay.
So last में I think I asked you about
Clausius theorem.
Clausius theorem. वो देखो Clausius theorem आपने आंसर नहीं किया उसको. ठीक है
सर Clausius theorem है कौन सी, मुझे याद नहीं.
Clausius अभी जो आप बता रहे थे that is related to that only. Okay, but
सर दो adiabatic paths जो,
हाँ, Clausius inequality and Clausius theorem, these are two different things ना. इसी से का conclusion है, from Clausius theorem only we are getting that Clausius inequality. ठीक है, second law of thermodynamics you will easily get that equation. So what is Carnot theorem, Clausius theorem, ये भी यहाँ से क्वेश्चन बन सकते हैं. Remaining all, like if I will compare your performance with your first interview, that is far better, like you improved a lot. So
yes,
things are fine, like you're working hard, that is reflecting from your interview. Okay. So keep preparing and good luck. Anything you want to ask, Baljinder?
हाँ ठीक है.
Good luck, keep preparing. Okay.
Thank you. So